Hello everyone, let's continue the second part of the Theodolite surveying unit. Today I am going to discuss about measurement of horizontal angles, vertical angles, deflection angles and some of the errors occurring in the Theodolite surveying work. So here for the measurement of horizontal angles by using Theodolite there are three methods. The first one is ordinary method, which is also called as a direct method. The second one is repetition method and the third one is reiteration method. Now let's move to the first method. Measurement of horizontal angles by ordinary method or direct method. Now here we have to measure an angle subtended between two objects, and here you can see the line AO and BO are intersecting at a common point O. So for measuring angle AOB, we have to keep the or place the instrument at station O and center the instrument and level the instrument with reference to the plate level. Now after leveling is done, unclamp the upper clamp screw and set the vernier A to 0 degrees accurately by using upper tangent screw. Now after setting the vernier A to 0 degrees, now loosen the lower clamp screw and direct the telescope towards object A and bisect object A accurately by using lower tangent screw. Now make sure that the vernier A readings is still reading to 0 degrees. Now after that, loosen the upper clamp screw and direct the telescope towards object B and bisect the object B accurately by using upper tangent screw. Now note down the readings of vernier A and vernier B, and the difference between the vernier A and vernier B readings must be equal to 180 degrees. Now change the face of the theodolite, which means plunge the telescope 180 degrees and swing the telescope 180 degrees. Now the vertical circle which was left to the telescope will come to the right side of the telescope observer. Now again measure the angle AOB as mentioned earlier, and now the mean value of face left observation and face right observation will give you the mean horizontal angle AOB. Now let's move to the next method, repetition method. Here the name itself suggests that the same angle will be measured for more than one time. So by this phenomenon, this method is very accurate compared to other methods, because the same angle will be measured for totally 6 times, by 3 times from the face left and 3 times from the face right. So the total 6 set of readings will be taken average, and the average angle will be the required horizontal angle. Now let's move to the procedure. As I mentioned earlier in the direct method, placing the theodolite at station O and setting the vernier A by unclamping the upper clamp screw is same, and again loosen the lower clamp screw and direct the telescope towards object A and bisect the object A. Now after that, unclamp the upper clamp screw and direct the telescope towards object B. Now read the vernier A and B readings and note it down. Now again loosen the lower clamp screw and bisect the object A. When you are measuring for the first time, the initial reading at A was 0 degrees and the final reading was something angle. So for example, if the angle AOB is 30 degrees, now for the initial reading it was 0 degrees at the first set and 30 degrees at second set. Now for the second repetition, the initial reading will be 30 degrees. And again, now loosen the upper clamp screw and direct the telescope towards object B, and now read the vernier A and B. Now the reading will be doubled. As the initial reading is 30 degrees, here again the angle AOB will be 30 degrees. So the 30 degrees of initial reading and the 30 degrees subtended between angle AOB will be added. Now it will show the vernier A and B will be showing an angle of 60 degrees. Now again loosen the lower clamp screw and bisect the object A, and again by loosening the upper clamp screw direct the telescope towards object B for third time. Now the reading AOB or the angle AOB will be tripled. Now the reading will be tripled. So for example, if the first set of reading was shown 30 degrees and the second was 60 degrees, now if it is tripled, then the angle will be showing now 90 degrees. Now after completing 3 set of readings from face left observation, again repeat the same procedure for face right observations. Now take all the average of face left and average of face right observations. The mean value of face left and face right observations will give you the horizontal angle AOB. Now let's move to the third method, measurement of horizontal angles by reiteration method. So here, whenever you are going to measure many angles or more number of angles on the field, you have to choose the reiteration method because it is less tedious and it saves the time. So in the reiteration method, you have to keep the instrument at the center and you can measure the angles all around the station. Now here the first reading or wherever you start the measurement of angles at the first station, it will be 0 degrees, and after complete the whole surveying work, when you lastly come again back to the first station, again the reading must be 0 degrees. So the initial reading and the final reading of reiteration method must be 0 degrees. So now let's learn about this method in detail. So keep the instrument at station O and center it and level it. Now by using the upper clamp screw, set the vernier A to 0 degrees and then by loosening the lower clamp screw, direct the telescope towards station S, object S, and bisect the S accurately. Now make sure that the vernier A and B readings will be reading 0 degrees and 180 degrees respectively. Now by loosening the upper clamp screw, turn the telescope towards P and now bisect the object P. Now read the vernier A and B and note down the readings and note down the angle SOP, and again unclamp the upper clamp screw and bisect the object Q, and now note down the readings of angle POQ. Again unclamp the upper clamp screw and direct the telescope towards object R, and now again note down the readings of vernier A and B by bisecting the object R. Now again unclamp the upper clamp screw and bisect again to the object S, from where you have started the measurement of angles. So now when you come back to the same station where you have started, the reading of vernier A and B must be same as the initial readings, which means you have kept 0 degrees in the vernier A when you have started the surveying work. Now again the reading must show you the 0 degrees when you bisect the object S. If it is not shown, the error must be distributed equally to the all the angles you have measured with keeping the telescope at the station O. Now let's move to the other method, the measurement of the vertical angles. Now we have learned about the measurement of horizontal angles. Now let's move to the measurement of vertical angles. Here vertical angle is an angle subtended between the inclined line of sight and horizontal line of sight. Here horizontal line of sight means the vernier circle, the vertical circle vernier must be reading 0 degrees, and if the vertical circle vernier doesn't read to the 0 degrees, then the line of sight may be called as inclined line of sight. The angle which is subtended between the inclined line of sight and the horizontal line of sight is known as vertical angle. The vertical angle may be classified in two divisions. The first one is angle of elevation and angle of depression. The angle which is above the horizontal line, the angle which is measured above the horizontal line is known as angle of elevation, which will be in positive nature, and the angle which is below the horizontal line will be known as angle of depression. Now let's talk about the procedure. Now keep the theodolite at the station and center it, and level the theodolite with reference to the altitude bubble. Whenever you measure the horizontal angles, you have to level the instrument with reference to plate level, but here now we are studying about vertical angles. So for measuring the vertical angles, you have to level the instrument with reference to the altitude level bubble tube. The altitude level bubble tube will be placed just beside the vertical circle. So now after leveling the instrument, bisect the telescope to the angle of depression or angle of elevation. If your object is below the ground surface or else below your station point, the angle will be angle of depression. The vertical angle may be called as angle of depression. And if you are going to measure a top of the tower, then bisect the telescope to the top of the tower and read the vernier C and D readings and note it down. The angle which is shown on vernier C and D will be the angle of elevation. Now this is the method of measuring the vertical angles. Now let's move to the other topic, measurement of deflection angles. See, the angle which is subtended between the prolongation of the preceding line and the succeeding line is known as deflection angle. Here you can see the station B is the main point. Here the line AB and BC are the two lines. Here AB is the preceding line. AB is the line which is behind the station B. Now the line BC is forwarded, which means the line BC is in the forward position. So you can see the direction A to B and B to C. Here the AB line is behind the station B and the line BC is forward. So this behind the line which is behind the station B can be called as preceding line, and the line which is starting from station B and ending at the station C is known as succeeding line. So here the prolongation of the preceding line, the angle which is subtended alpha 1 is the angle which is subtended or formed between the lines AB which is prolonged and the line BC. The angle subtended between the prolongation of the line AB and BC is known as deflection angle. Here, if the deflection angle is towards the right side, here you can see you have to measure the angle from BA dash to BC. So the direction is clockwise. So if the deflection angle is clockwise, it is called as right deflection angle, and here you can see the angle here alpha 1 L. Here this deflection angle is towards left side, which means anti-clockwise. So this is called as left deflection angle. So the measurement of deflection angles is most suitable for open traversing. See, you can observe open traversing in aligning the highways, railways, canals. So wherever the open traversing is required. So now let's learn about the procedure. Now keep the or place the place the theodolite at station B and do all the temporary adjustments, which means centering and leveling. Here we are measuring horizontal angles, so we have to level the instrument with reference to the plate level. Then set the vernier A to 0 degrees. Then take a back sight on station A or object A. Now take back sight on object A. Bisect the object A and tighten the upper clamp screw and lower clamp screw. Both the upper clamp screw and lower clamp screw must be tightened. Now just transit the telescope. Now transit the telescope towards A dash. Now the line AB will be prolonged. After making the line AB prolonged, now again loosen the upper clamp screw and bisect the telescope towards C and bisect the object C accurately by using upper tangent screw, and note down the readings vernier A and vernier B of A dash B C dash. So note down the angle A dash B C dash, and then again direct the telescope towards, by loosening the lower clamp screw, direct the telescope towards object A and bisect the object A accurately, and again by tightening the upper clamp screw and lower clamp screw, set the vernier A to 0 degrees and again transit the telescope towards A dash. Now again by loosening the upper clamp screw, bisect the object C and read the vernier A and vernier B, and this will give you the face right observation. If you have measured face left observation for the first time, then the second set will give you the face right observation. So the mean value of face left and face right observations will give you the mean value of the deflection angle subtended at A dash B C. So this completes the topic measurement of deflection angles. Now let's move to the last topic of this unit, errors in theodolite work. So here there are different errors which will occur in the surveying work by using theodolite. So the first one may be the errors may be classified as instrumental errors, personal errors, natural errors, and mistakes, and some of the mistakes. Now let's start with instrumental errors. See, instrumental errors means the instrument itself is not correct, which means the instrument is somewhat compromised, which means the instrument is not very good. So here the first one is due to imperfect adjustments of plate level. See, if the bubble tube is not showing at the center, when you are going to level the instrument, if the bubble tube doesn't come to the center at any cost, then the sensitivity of the bubble tube will be lost. So that is an instrumental error. And when you bisect or when you set the vernier A to 0 degrees, the line of sight which is not perpendicular to the horizontal axis. If the line of sight is not perpendicular to the horizontal axis, then the instrument can be called as having some of the instrumental error. So the next one is due to horizontal axis not being perpendicular to the vertical axis. The horizontal axis which is passing through the center of the two standards, which means A frame. So the center of the A frame, so through which the vertical circle and the telescope rotates in vertical plane, that axis is known as horizontal axis. If that horizontal axis is not perpendicular to vertical axis, then the instrument is in error. Now the next one is due to imperfect adjustment of vertical circle vernier. See, in the theodolite, if the vertical circle which is used to measure the vertical angles, if it is not properly adjusted in the instrument, then the instrument is in error. Now the next one is due to eccentricity of outer and inner axis. So we have already seen the outer spindle and inner spindle in the previous video. So if both the common thing is between the outer spindle and inner spindle was the vertical axis which was passing exactly at the center of these both spindles. Now if these both are eccentric to each other, then the vertical axis will be differed. So the vertical axis passing through the outer spindle and the vertical axis passing through the inner spindle, both will differ. Actually, the vertical axis passing through outer and inner spindle must coincide. If it is not coincided, then there will be eccentricity, which means there will be an error in the instrument. So the next one is due to imperfect graduation on the horizontal scale. So when you are going to measure the horizontal angles, you will use the horizontal scale. So if the graduations, which means if the numbering system or measuring scale, if it is not correct, then the instrument is said to be in error. Now let's move to the personal errors. So personal errors means the observer or the surveyor who is working with the theodolite will going to make some of the mistakes while surveying. So the first one is due to inaccurate centering. See, some of us will do just keep the theodolite at the station, and we won't be we won't make sure that the instrument is exactly on the center of the station. So that is the personal error. And the second one is due to inaccurate leveling. So sometimes we forget, or we omit doing the leveling part. So we have to level the instrument with reference to plate level and altitude level. But if we omit the leveling of the instrument, then that will be a personal error. Now the next one is slip in screws. So the foot screws, if the thread of the slip, uh, uh, if we are rotating the foot screws in the wrong manner, then that will be the personal error. We have to rotate the foot screws either inwards or outwards. If we are rotating the foot screws both in the same direction, then that will be an error. Now the next one is improper use of tangent screws. So the tangent screws are provided for the accurate bisection of the object and points which we are going to measure. If you are not using the tangent screws for the accurate bisection, then it will be called as personal error. The next one is inaccurate vernier reading. So some of us will read wrong graduations on the vernier scales which are provided in the theodolite. So the improper or inaccurate reading of the vernier will be a personal error. So the next one is inaccurate sighting. So inaccurate sighting means we have to bisect the object exactly at the center. If we are bisecting the object slightly sidewise, then it will be called as personal error. Next one is the parallax. So the next error is called as parallax. Parallax means the object which we are observing will not be in the plane of the vision, or we can call it as it will not be focused accurately. So the next set of errors are natural errors. See, these are uncontrollable. Personal errors can be controlled by making the observer or the surveyor to make sure that he does all the work exactly. Now in the natural errors, we cannot restrict the natural errors, or we cannot overcome the natural errors. See the temperature effect. So temperature effect, which is related to the cold and hot seasons. So the next one is wind effect. Whether if the wind is very faster, then the theodolite instrument will be shaking. So that is also an error which is caused by nature. And the next one is refraction effect. Sometimes when we are surveying for long distance in the sunlight, the light will be refracted, and that will make an error to the surveying work. That is also comes under natural error. And the next one is unequal settlement of tripod. So if the three legs of tripods are on this stable ground, then the instrument will be good in condition. Or else, if the three legs are on the soft ground, when we are surveying, due to the weight of the theodolite, sometimes the tripod legs will be sunken into the ground. So that will make an error to the surveying work, which may be classified under natural errors. So some of the mistakes. So mistakes we do in the theodolite surveying works. So mistakes, sometimes we forget the leveling instrument. sometimes misreading the vernier and dropping one division on the main scale. See, when we are reading, if we drop the uh, reading on the main scale, which means we have to measure minutes also on the main scale. If we omit the minute scale, then that will be an error. So this completes the second part of the Theodolite surveying unit. So this completes the introduction part. Next, the problematic part will be uploaded very soon. Thank you.